Hello, it's dumplet here. Here's an item on geometry. We have two equilateral triangles and a circle as seen in the figure. So the blue equilateral triangle is inscribed in the black circle, and then another red equilateral triangle is drawn as you can see in the figure. And then this vertex over here, so one of the vertex of the red equilateral triangle, that is going to be the midpoint of one of the sides of the blue equilateral triangle. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, the question asks us to get the ratio of the areas of the two equilateral triangles. Now, they are equilateral, so they are also similar. So we could just simply use the fact that, okay, I'm just going to let the blue side to be B, the red side to be R. So we know that the ratio of their areas will just be the square of the ratio of their sides. So if I can manage to get what B and R, or what's the relationship between B and R, all I have to do is just square this. So that's going to be what I want. Okay, now as with a lot of geometry questions, I thought at the start I would do probably some trigonometry, probably draw some lines. So well, I do realize that there is an axis of symmetry here. And I also tried drawing out these two because they seem important, and tried to do some length chasing, tried to write down some angles, but I did not reach anything with this method. So I decided to scrap this idea and go back to the first thing I just mentioned, the axis of symmetry we have over here. So having this axis of symmetry, I say this is pretty good. Now the reason for that is because it motivates me to do what I'm going to show you. Now, this might be obvious to some, but I'm going to say whenever you have nice symmetry and nice figures, because technically speaking, I could say that, well, I do have this other line. It's not an axis of symmetry, but it's pretty good because it's perpendicular to the axis of symmetry. So maybe a lot of symmetrical figures. Maybe I could use some symmetry and ratios to help me solve the question. So this motivated me to use the Cartesian coordinates because we have a circle, which is not going to be that difficult because the equation in the Cartesian coordinates, it's not that bad. And we do have equilateral triangles. So the nice lengths and angle conditions would allow me to probably write some of these segments into equations of lines and get the result that I want. So in Cartesian coordinates, I just set this. So the intersection of the one vertex of the red equilateral triangle, which is also the midpoint of one of the blue sides, I set it to be 0, 0. And the question isn't too specific about the length, so I'm just going to say, without loss of generality, I'm going to set this point. That's going to be the circumcenter of the triangle. I'm going to set it at 0, 1. Right? I'm just going to say, right? Usually we use O to denote the circumcenter. So the circumcenter is at 0, 1. Now, well, we do want the lengths of the blues and the red segments. So I decided to try to focus on getting these two, right? These two yellow points, because those two yellow points should determine the length of the blue segment. And well, I already have 0, 0 over here. So my other goal is to find this one, this red point, to help me get the length of the red segment. And because of how we have nice symmetry in the figure, and because of how this blue segment it's actually going to, okay, we could do some angle chasing here. Well, we do know this is 60 degrees, this entire thing. So this would be half of 60 degrees. And because we do have the nice axis of symmetry in the middle, this would be both be 30 as well. So essentially, I do have two parallel lines. So the blue and the red segments, they are parallel, which will be good in Cartesian coordinates because their slopes, so let's just say those two are part of the lines, their slopes would be the same. So that's going to be, I'm going to say that's going to be a little bit easier for us to get some of the coordinates here. Now, let's try to get the yellow segments first because, well, this point, despite being a circumcenter, it is also the centroid, the orthocenter. So there's a lot of, because it is an equilateral triangle. So this point is also the centroid, and this segment over here, right, this segment, that's also the median to one of the sides. So we do know that the median separates, we do know that the centroid splits the median into two segments in the ratio 1:2. Now we do know that this has a length of 1, so the longer segment, it should correspond to a ratio of 2, which should give me 2. And that's going to be enough for me to say that, okay, this point must be 0, 3. Right? That must be 0, 3. So that's 1 point down. So let's try to focus on the other point. The other point is not that difficult to get as well, just a bit of trigonometry. So this is 60 degrees. Because we do have an equilateral triangle, I'm going to take the tangent of 60 degrees in this triangle. Taking the tangent of 60 degrees in this triangle. Take note, since this part is an altitude, we can kind of rely on symmetry as well. That angle must be right. So I'm going to take the tangent of 60 degrees. That should give me, well, this part has a length of 3 divided by this part, let's just call it x. So that's going to be x. Now tangent 60 degrees is square root 3. So that's going to give me that x would have to be the square root of 3. Now, since x is the square root of 3, so I'm moving square root of 3 units from this origin. So this yellow point would have the coordinates negative square root 3, comma 0, right? And that's going to be done for the blue segment. I knew I could just take the distance formula and get the distance of these two yellow points, and that's going to become the blue segment. But we're going to talk about it in a while. Now, next, for the red segment, we already have the origin, but we do need this additional point, which, well, it is on the circle. So when talking about Cartesian coordinates, we can say that, well, it's just going to be the intersection of this yellow line, right? This line. Because that's the red segment is on this yellow line. So it's going to be the intersection of that yellow line and the circle. So I think we might want to get the equation of the circle as well, which is not too difficult because we already have the circumcenter. So the center is at 0, 1, and we do know the radius as well. It's going to be this portion, so this length of 2, that's going to serve as the radius. So we do know that the equation of the circle is x squared plus y minus 1 squared. And then the radius is 2, so r squared is going to be 4. We're going to use that in a while. Now, the next thing that we have to talk about is what's the equation of this yellow line? So what's the equation of this yellow line? Now we do know the slope because the slope is exactly the same as this blue segment, right? This part, it has the exact same slope as this one, and we do know that the slope of a line is equal to the tangent of the angle it makes with the horizontal axis. So, well, we can say that the slope is going to be tangent 60 degrees as well, right? The slope of the line is going to be tangent 60 degrees as well, right? So that's going to be a property of lines. So we have a slope to be tangent of 60 degrees, which is square root of 3, and it passes through the origin, 0, 0. So I could write the equation as, okay, y minus 0 is equal to the slope, which is tangent 60 degrees, so square root of 3, times x minus 0. So the equation of that yellow line is y equals square root of 3 times x. And what I have to do is just take the intersection of these two. But I have to be careful because the reason why I drew out this yellow line is because essentially there are two intersection points, right? This point that we want and this additional point that we do not want. So we don't want this point up here. So we have to kind of restrict the values of x and y for us to get the correct point. Now, with respect to this Cartesian coordinates, with respect to the plane we've set up, the point that we want is in the third quadrant, right? We want a point in the third quadrant. It's this region. So this region is the third quadrant. So we would expect both x and y to be negative. So that's going to be what we want. So even if we get a positive value for x, we're going to reject that. I think that's going to correspond to this point. So we don't want the point in the first quadrant, we want the point in the third quadrant. So let's try to take the intersection of the green line in this case, which we know the equation of already. It's going to be y equals the square root of 3 times x, and I just have to take the intersection of these two. Now, no easy way for us to solve the question but to literally substitute y in. So x squared plus square root of 3 times x minus 1 squared, that's going to be equal to 4. So x squared plus 3x squared minus 2 square root of 3 times x plus 1. I'm going to put the 4 to the other side. So I'll have 4x squared minus 2 square root of 3x minus 3. That's equal to 0. Now, I would be able to solve the value of x here. And based from what I realized a while ago, I think the x that we have to get is going to be negative because this point that we want, it's technically in the third quadrant of the Cartesian plane that we set up. So solving for x is going to be equal to, so negative b plus minus, b squared is going to be 2 square root of 3 when squared, so 12, minus 4ac, so minus 4 times negative 3, so essentially a plus 48. So 12 plus 48, that's going to be the square root of 60, which is 2 square root 15, divided by 2a. So it's going to be square root of 3 plus minus square root of 15 over 4. And we don't want to take the positive sign, because if I take the positive sign, x would be positive. So we have to take the negative sign over here. So the value of x that we want, it's going to be negative square root of 3. Sorry, it's going to be square root of 3 minus the square root of 15 divided by 4. Now for the y value, we just simply substitute it in. So this is the x value that we got. And then this would be the y value that we get, since we do know that y is going to be equal to the square root of 3 times whatever this thing is. So times x. We do know that x is this one. So that's going to give us this to be the value of y. Now, going back to the blue and the red segment that I talked a while ago, we now have all the points that we need. So the blue segment has endpoints. These two, the 0, 3, and the negative square root of 3 and 0. And the endpoint of the red segment is going to be the origin, and then this point that we just acquired, it's going to be that. So we just have to take the distance via the distance formula, and we just need the squares of the lengths anyway, so that's good because the distance formula gives us the distance squared anyway, so that's pretty interesting. So let's try to get the b squared, which is the blue segment squared. Okay, that's going to be right, the difference in x when squared, so that's going to be 3. The difference of y when squared, that's going to be 9. So b squared is 12. That's fairly simple. Now for the red one, it's going to be a bigger value. So we want the value of, right, squaring the first term, we're going to get something over 16. So we're going to get 18 minus 6 square root of 5. And then squaring the second term, that's going to become, a plus something over 16 again. So it's going to be 9 plus 45, so 54, minus 18 square root of 5. All right, so adding these two together, we're going to get 72 minus 24 square root of 5 divided by 16. Okay, we could write this in lowest terms. So it's going to be 9 minus 3 square root of 5 divided by 2. All right, so the last goal is to just divide b squared by r squared. Now, so it's 12 divided by 9 minus 3 square root 5 divided by 2. Now let's multiply 2 to the numerator and the denominator to clear the complex fraction. So 24 divided by 18 minus, 24 divided by 9 minus 3 square root 5. All right, we could cancel out the 3. 8 divided by 3 minus square root 5. We could rationalize this. So times 3 plus square root 5 in the numerator and the denominator. That's going to give me 24. Oh, actually, I could just write it as like this. And we can see that the denominator is just a difference of 2 squares. So that becomes 9 minus 5. That's going to be a 4. So 8 and the 4 cancels out. So it's just going to be a 2 in the numerator. So 2 times the square root of 3. 2 times 3 plus the square root of 5. That's going to be 6 plus 2 square root of 5. So it's not going to be an exact ratio, but it's going to be an exact ratio, not an exact integer though. So this value though, if you want to take the value, I think it's approximately 10.47. So that's going to be the ratio of the blue area to the red area, and this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.